Hello, everyone, and thank you for coming to listen to my presentation. My name is JRollins, and I was mentored by John Kubala, who's a structural engineer. I was mentored with Kubala engineers. Throughout the course of my mentorship, I participated in site assessments and designing different buildings for different load combinations, and really just got an in-depth view of what it means to be a structural engineer. It was a wonderful mentorship. It was something that I will look back on with fond memories, and it was something that I would definitely recommend to anyone who is interested. So today I'm going to be doing my topic on the future of sustainability in construction. And so first we have to ask ourselves, well, what even is the big deal? Why does construction need to be more sustainable? Well, actually, according to the UN Environment Global Status Report, buildings and their construction together account for nearly 36% of global energy use and 39% of energy-related carbon dioxide emissions annually. And this is a statistic that kind of shocked me. I wasn't exactly totally unknowing about how emissions worked within construction, but I didn't think that it would be this high of a number. I thought it would be much lower. And so I thought, well, maybe if we can make this even a little bit more sustainable, we can cut out a large part of emissions in the world today. So I wanted to try to find a topic that covered that. So when we talk about sustainability in construction, most people think, do we need a super green house with solar panels or vents and operable windows or a rainwater collection? And so while these things are kind of on the right track, and while, a house that's designed like this, while those do represent a form of sustainability in construction, they're not exactly what I want to focus on. And before I go into these specifics of what I conducted my research review on, I want to look at just a couple possible solutions for the future. And so on the left, we have an example of a large scale 3D modeling press where concrete would be used as the filament, and a technician would be able to design and build a house in almost a day or two. And this would incredibly streamline the process. Of constructing buildings. It would cut down on waste because according to the UN environmental report, nearly 9% of the energy related issues comes from construction waste. And so another aspect that kind of deals with this construction waste issue is the concept of prefabrication, where instead of sending materials to a site to be built, we actually build the materials, we build offsite and then transfer the pre-constructed substructures to the site, where then they're kind of put together like jigsaw pieces. And, while there are some benefits, especially towards cutting down waste, there, especially with the 3D printing press that would use the 3D printing module that would use concrete. Currently, right now, concrete is actually the third leader in emissions if it were to be considered a country behind the USA and China. And part of that comes from the fact that there's a chemical compound in the binding portion of concrete known as clinker. And this is an extremely emission prone when it's sent through the furnace to create concrete. As a matter of fact, in 2015, in 2015 alone, 5.2 billion tons of carbon were emitted in the environment. And so obviously we don't want to continue to emit that much carbon. So now I kind of want to talk about specifically what I wanted to focus on. Well, when we think about structural engineering, and one of the things that I thought, it's about the beams and the members and everything that's connecting a building to keep it standing upright. And so we have these giant metal beams, and that's mostly what people think. That's the only thing that can be used in construction. Well, actually, that's not true. We have trees that almost in nature that almost naturally mirror these giant beams, and they're self-supporting structures similar to the beams. And so as a matter of fact, the future is actually a simpler solution from the past. On the left, we have an example of how the wood is compressed and bonded together. And then on the right, we have an example of how it can be used with concrete to support large scale buildings in urban environments. So what I wanted to specifically focus my research review on was the emergence of the re-emergence rather of cross-laminated timber in the construction market today. On the left, you can see an example of how wood can be used in the floor. It can be used in the columns that support the floors and, or the beams rather, that support the floors, and the columns that support the vertical displacement of the load combinations. And so one of the things that when I was talking to people about this, so why isn't wood used more in an urban environment? Well, part of it stems from especially if it's capable of transmitting the loads in the exact same manner that steel and concrete are. Well, part of the problem is that the International Business Code until 2021, they actually didn't allow buildings to be used with mass timber or cross-laminated timber rather. They were not allowed to be created over 3 stories. And so that's not feasible where you need buildings to be up to, northwards of 20 stories. And part of this stems from the fact that when there were fires in cities, especially the Great Chicago Fire, the buildings that were made with wood were burned completely to ash, while the buildings that were made with brick and mortar, or steel and cement, they were actually able to withstand the fires a little bit better. And so people didn't kind of shifted away from using wood to build in urban environments after this, especially once the regulations were implied that they could no longer use them. And so when we talk about the benefits of cross-laminated timber, is it's actually an incredibly technologically advanced process. What you do is you take lower scales of wood and you compress them together, and then you take these compressed boards and you lay them on top of one another, and then you compress that and glue those together to create something that's almost as strong, if not as strong, as steel. I mean, when I was talking with my mentor, Mr. Kubala, said if you have wood, you're capable of designing on the exact same manner that you would for a steel beam. The third concept, which you see here, it's kind of a tricky word, but it's known as carbon sequestration. And so this was something that was new to me. It was a concept that I came across when I was reading literature on the internet. Carbon sequestration actually deals with the fact that steel, right, and other materials that we use in construction, they're emitting emissions into the atmosphere. As a matter of fact, 1 ton of steel is linked to 1.85 tons of carbon dioxide emitted. While a house that's made with wood actually sequesters, because you don't have to create any new emissions, and throughout its natural lifetime, trees actually take in carbon instead of expelling it. And so a typical house actually locks up 10 to 19 tons of carbon every house. These estimates are according to the Environmental Protection Agency. The fourth concept is the concept of aesthetic appeal. And so when we look at the anecdotal evidence, a lot of people that are in these buildings say that they feel more relieved because they feel like they're in a park setting or something that's more comfortable than standard steel and concrete buildings. So just some of the new emergences that have come out in recent years and have allowed the approved codes to be able to build large scale buildings is that there's been new fire tests that have proved that cross-laminated timber is capable of supporting buildings, and it doesn't immediately fail the way that some people would have expected would to. And so part of this comes from the fire resiliency of the cross-laminated timber, because when there's a fire, what actually happens is the outside of the material is burned and charred, but the inside of the material is left intact. Excuse me, is left intact and is actually and is actually still able to support and transmits loads, the load combinations in a safe manner so that the building is able to remain standing upright. And so and one of the other benefits of the mass timber is that when you look at a comparative life cycle assessment, sorry, excuse me, when you look at the comparative life cycle assessment of a mass timber building and its concrete alternative, which is a study done by the Forest Products Society in April of 2020. And so what they did is they took a 12-story building in Portland and then compared it to a concrete building, and then one that concrete and steel, and then one that used mass timber for the beams. And so what they noticed that there's actually an 18% reduction in factors contributing to global warming with the mass timber building. And there's the interesting number was that there was a 439 increase in the life cycle renewable impact assessment. And so part of that stems from the fact that concrete and steel can only be used once, while the mass timber can actually be used and then broken down and then used to recreate more mass timber that can be used in different buildings after it's already been after buildings are demolished, while concrete and steel tend to be more they tend to be less renewable. And so while there are many interesting things happening in the field, there are some complications. Currently, there's only 2 to 8 suppliers across the United States. Currently, there are 3 to 5 more in development, pending on funding. But because there aren't large number of manufacturers, especially comparative to the number of people and businesses who create concrete and steel, it becomes extremely uncost effective to design buildings in this manner. And then the second concept is the concept of increased deforestation. Environmentalists are worried that if we switch to a cross-laminated timber as the main source, then more trees are going to be cut down. But one of the interesting things is that the cross-laminated timber doesn't have to use large growth, older trees. It can use young trees that aren't as big, and then they can be compacted, and those can be used to create the cross-laminated timber beams. And then the third concept is related to the effects of global warming, carbon sequestration. Right now, environmentalists are calling for a more in-depth studies to see exactly how much carbon is sequestered compared to steel, because if it is only a little bit more expensive to use the mass timber, but we are able to cut out large parts of emissions, then maybe that is something that can be used to further the argument as to why we need to transition away from concrete and steel towards more mass timber in our environments. And so then basically some of the next steps that have to happen if cross-laminated timber is able to emerge as an alternative to steel is that there has to be an increase in the number of manufacturers. If there's an increase in the number of manufacturers, it will cut down on costs, and it will also it will allow more buildings to be constructed from cross-laminated timber. And one of the companies that is kind of leading the charge is this. They're known as Katerra, and they're based in Canada. But they are designing a building in Chicago that's planned to be 18 stories and is going to be built in the next 2 to 3 years. So as we look towards the future, 68% of the world's population is going to be in urban areas. Nearly 2 billion housing units are by the 68% is by 2050, and then 2 billion housing units need to be created for over the next 80 years. And so currently we already have incredibly high emissions in our environments today. And if we're not careful, that is going to have serious and drastic, far-reaching consequences. But if we can transition to something that's a little bit more sustainable, like this cross-laminated timber hopes to be, maybe we can cut down on those emissions and create a more sustainable future. So currently I'm on track to study aerospace engineering at UT Austin. And one of the things that I really want to take forward from the mentorship is how you look at the different load combinations. And so on Mars, for example, there's different atmospheres, there's different types of storms that you'd have to worry about when you're designing the habitats. And hopefully, if after graduation, when I'm working with NASA or with other uh, space companies, I can use the same concepts that I've learned and apply them to other planets to be able to design habitats that can withstand the extreme loads of other planets. And so once again, I just want to give a special thanks to Kabbalah Engineers for mentoring me. And then I also want to thank the Gifted and Talented program and Miss Bryant in particular. This program was amazing for me. And in a year when things were kind of tough with COVID, it was always a highlight of mine that I looked forward to each week. So once again, thank you so much for watching my presentation, and I hope you have a great day. Thank you. Bye-bye.